Angle relationships, lesson 1. In this lesson we're going to look at, eventually we're going to look at two lines that are crossed by a third line and examine the pairs of relationships between angles that exist there. But before that we're going to do a review for most of you, and that review is going to cover classification of angles. We're going to spend some time on special angles and look at angle pairs when two lines are crossed or touch, to get us ready for when when two lines are crossed by another line. We're also going to do two proofs. We're going to prove that angle pairs that are across from each other are equal, and we're going to prove that the sum of two pairs of angles that are along the same line sum to 180 degrees. Classification of angles. You're going to see that definitions are coming up. I'm going to go through this fairly rapidly because it's review. If some of you find that it's going too fast, you can slow this down, pause it to review the information. I'm showing a 360 degree protractor, and in this case from 0 on the right side to looking at the angle measure here, we're finding that it's 115 degrees. And angles can measure from 0 to 360 degrees, I mean a full circle. Angles with no measures are called zero angles. Angles of 360 degrees are called full rotation angles. Angles of 180 degrees are called straight angles. Okay, looking at some special angles. A right angle is an angle whose measure is exactly 90 degrees. And you can see from the second example is that it doesn't have to be 0 to 90. It can also be 40 to 130 or anything in between where the difference between the angles is 90 degrees. Something that's fairly easy, though, you'll find in most math texts and books and workbooks, is that if you can put a small square perfectly between the angles, it really is an indication of 90 degrees. I'll show you several of these, and you can see they can come in various rotations. One of the things to remember is real critical is that any time you see a box in the corner of the intersection of two lines that form 90 degrees, often you will not see 90 degrees, you'll see this box. So it's something to remember. Okay, let's look at acute angles. Okay, acute angles are angles whose measure is less than 90 degrees, and previously I showed you shadow of the 90 degree angles, and you can see that these acute angles are less than 90 degrees, and therefore the box does not perfectly fit at the intersection of these two lines. Similar with obtuse angles, they are greater than 90 degrees but less than 180 degrees, and you can see how these sample angles have extended over 90 degrees. Let's do a quick test of understanding. Angles with no measures are called what? A, B, C, D, or E. They are zero measure angles. A small square in the corner where two lines meet measures what degree and identifies what special angle. You can see our angle in our box. Is it A, B, C, or D? Correct answer is B, 90 degrees, a right angle. The next is, what are straight angles? A, B, C, D, and E. and as before, angles equal to 180 degrees are straight angles. And I'm going to show there are 4 different angles here. Which of these angles are acute or obtuse? And there are a list of A through F. Correct answer is E. Angles A and C are acute. Now, let's look at angle pairs when 2 lines cross or touch. We're going to start off with our obtuse angle that we had before, and we're just going to extend in both directions beyond the touching point so that we have angles that are produced when those lines are crossed. So we have 4 angles. And we're going to do the same thing with an acute angle that we saw before, extend those out. And now we're going to look at angle pairs. Okay, angle pairs across from each other when 2 lines cross are equal. So we can see that this pair of angles represented in red on the left side and the pair of angles on the right in red, those angles are equal to each other. Okay. Let's look at the blue angles. Those are across from each other as well in both of the figures, and those blue angles are equal to each other as well. Now, when angle pairs along the same line, let's look at those. They will sum to 180 degrees or a straight angle. And they are indicated by the red and blue indicators here. Let's prove that angle pairs across from each other are equal and that angle pairs along the same line sum to 180 degrees. Let's take our crossed angles, cross lines here. We're going to examine the angles in red. You're going to take our protractor, 180 degree protractor. We're going to measure from 0 to its measure. It's 78 degrees. Okay, on the right side, we're going to measure the angle across from it. It also measures 78 degrees. Therefore, angles across from each other are equal when 2 lines cross. Now let's prove that angle pairs along the same line sum to 180 degrees. And previously we had the angle on the right, the red, and we proved that, well, we did the measure and showed that that's 78 degrees. And if we do the measure of the angle indicated in blue, we see that that measure is 102 degrees. So the sum of those angles, 78 plus 102, equal 180 degrees, or a straight line. Now let's do a quick test for understanding. 2 lines cross. If angle A is 39.5 degrees, 39.5 degrees, what is the measure of angle B? Is it A, B, C, D, or none of the above? And the answer is 39.5 degrees. If 2 lines cross and angle A is x plus 9.5 degrees, what is the measure of B, of angle B? The measure of angle B is A, x plus 9.5 degrees. Congratulations, you have completed Angle Relationships Lesson 1. In Angle Relationships Lesson 2, we're going to look at various types of angle pairs from parallel lines that are crossed by another line, and we're going to solve their algebraic expressions.